So we're going to do more of these Riemann sums, but today they're going to be not right-hand and left-hand sums. They're going to be midpoint and trapezoid sums. So that's the plan for today. Bye. Okay, so here's a midpoint sum, and notice that each one of those rectangles are touching the curve that they're estimating the area for. Each one of those rectangles are touching the curve at their midpoint of their top there, right? So that's what we mean by a midpoint sum, all right? So, of course, we're going to start by practicing that horrific process of drawing these things. So, go ahead and find example one. You guys can do this with me. I'm going to try to slow down a little bit. I went too quick with you guys when we did the drawing last time, and then I changed how I did it with the second period. We slowed down. I had them kind of do it with me. They got it a little bit better. They still had a hard time, though. Drawing these things is tough. But so here we go. How do we draw a midpoint sum? So here's how you're going to do it. Look at the x values that we have. Like what's the x value that's farthest to the left? -3. What's the next x value dot that we care about? -1. Now what is the middle x value there? -2. So what we're going to do is we're going to start at -2. We're going to go up until we get to our line, and we're going to draw a dot there. So at -2 is where you're going to put a new dot on your line right there. You're going to put a dot at the middle x value between the two values that they actually give you. And then what you're going to do is you're going to draw a horizontal line, but this time it's going to go both ways, right? Because it's the middle, like that. There's your first rectangle. Okay? Now let's do the next one. All right, so let me kind of ask you guys, well, why don't you try to find the middle dot? Like where should you put a dot on your curve? Go ahead and find it and see if you guys can draw that dot on your curve really quick. Vivian, where should I put my dot? Do you want to come draw it, or do you want to tell me where to put it? For the next dot, yeah. So like what we did was we said, okay, here's my first x value, next x value, find the middle one and go up and put a dot on the curve there, right? So where did you put your next dot? So like, Pete, you want to come put a dot? Like, I don't know what you mean. Can you come just draw it for me? Okay, not bad. That's not bad. I like it. I like it. I'm gonna say we can go better than that, but you're close. You're close. All right. Now let's kind of think our way through it a little bit. So my next rectangle I'm gonna draw. The first rectangle went from -3 to -1. What's my next rectangle gonna go from? -1 to 1. Now, yeah. So the middle x value is 0. So if I'm at 0 and I go straight up, that would put you right there. Does that make sense? So you were close, and because if you just go over a little bit more, that would put you that high, right? But that's where we're at. So now go ahead and turn that into a rectangle. Try it on your paper, see how you guys do. So remember, when you're drawing this rectangle, that's a midpoint, right? So let me ask if Mateo, would you come draw the rectangle that would go there? Okay, thanks, sir. That's correct. So now the next one's going to make you feel weird. But if you just follow the steps and don't do anything different, we can get it. All right, so let me walk you guys through a little bit. John B., my next rectangle is going to go from what x value to what x value? 1 to 3. So Matthew, what middle x value am I going to put a dot at then? At x equals 2. I want you guys to see if you can put a dot on your graph where x equals 2. Go ahead. I'm going to ask Michael, would you like to come show us where you put your dot? Good, thank you, sir. So he's right. And now we want to draw a rectangle. What do you think, Graydon? You ready? No? You don't want to try? Think for a minute. I'll give you some thinking time. Just want to turn it into a rectangle now. Maybe. Come show me. It's okay to be wrong. That's not true. I've seen you solve Rubik's Cube before. It is different.
Oh no, but how much is it assumed? Quite possibly.
He just contradicted himself. He's not always wrong. That's correct. Nice job, Graydon. All right. So I'm going to let you guys try to draw your last rectangle. Go ahead and draw your last rectangle. Let's see if you can get the last one on there, and I'll show you in a second. So here's my first x value, my last x value for that last rectangle there. We're going from 3 to 5. The middle would be at 4. The dot would be there. If that's the midpoint, then your rectangle, remember, you go to the x-axis, right, would look like that. It's an upside-down rectangle. And now we can get our area. What's the area of this rectangle over here on the left?
2.
Next one?
2.
Next one?
6.
Last one. Is that right?
Yeah.
Okay, so we have 2 is the answer. Final answer. The 8 canceled out a lot of the area, so we got 2. All right, so that's what we call a midpoint sum. I'll let you guys do one more here from beginning to end. You guys do it. See if you can find for me the total area under that curve using a midpoint sum estimation. There's our rectangles there. So this one has an area of 8, -2, +2. Those are just going to cancel. They're symmetrical. And then this is 8, so we're just left with 16 as our estimate for the area under the curve. Okay? So that's a midpoint sum with a graph. I do the graph problems because I want you to understand what we're doing, because it really is it's a geometry thing. But I always segue into tables and equations after that, because that's how it's going to be presented to you. They're not usually going to give it to you in the format of a graph usually. All right, so let's go ahead and take a look at example 2. All right, so we're doing a midpoint sum, right? They also want 4 equal subintervals. So if I want, oh no, please, after you.
Okay. After me, no.
I'm just kidding. All right, but you guys should pay attention. All right, here we go. If I want to find 4 equal subintervals, I'm going to use my cards first here. Pearl, if I want to find 4 equal subintervals, what do I do? Good. Good. Good memory. I like how you worded it. X last minus x first over subintervals. So that would be 12 is my last x value. My first x value is -4. And I want 4 subintervals. And that's 4. Okay? Bonus points. What does 12 minus a -4 tell me? What does that tell me about this? The width of what? Not the width of a rectangle. What does 12 minus -4, what is that? 16, right? So what does that tell me the width of, if you want to call it that? The whole graph. In other words, how far the graph is, right? So that's what we're looking at. The next thing that we're looking at is the 4. What is this 4 here? This 4 tells me how many pieces we have. We have 4 pieces. That's what they want, 4 subintervals. But what does this 4 tell me? So you want to raise your hand and tell me that one? This guy. The bottom 4 is how many subintervals, how many rectangles we have. Good, good. How are you going to say it, Mateo? Because there's another way to say it, but I'll take that. The width of the rectangle. So I like how you word it, because that's what it's going to look like here. But we want to think geometrically too. That's the width of each rectangle. So let me jot these down real quick. Okay, so So we're jumping by 4s, right? So we start here, we jump there. So we go up by 4. We jump 4 again, we jump 4 again, and we jump 4 again. And each one of those represent my width of my rectangle, which we can also call delta x, the change in x for each rectangle, okay? And how many of those do I have? 4. I've got 4 4s, right? Because they wanted 4 equal subintervals. Okay, now we're going to do the midpoint sum. So now this is where I'm going to ask you guys to think a little bit. You already know the answer? Which y values represent the height? So I'm going to pick all 3 of you guys, but let me start with Mateo. Tell me one of my heights.
3.
Good. What's the other one, Pearl? Good. Did you want to do one, Graydon?
Oh, sure.
What's the next one?
7.
7. And so how do we know which it is? Well, it's always the y value, the height that's in the middle. Like, so here's a rectangle, right? That's the height that's in the middle. That's the midpoint of your rectangle. That's the y, that's the height that we care about. And so the next one would be from 0 up to 4. The midpoint for that one would be 3. The next one would be from 4 up to 8. The midpoint for that one is there. The last one would be from 8 to 12, whose midpoint is there. So those are our heights. So you don't need to actually draw the shape. You can just say, okay, there's the widths of my rectangles, and these are my heights. And from there, we're good. It's base times height, base times height, base times height, base times height. And so adding all that up, you can get a final answer. I'm going to leave it. I'm just going to be lazy like that because like a lot of times in FRQs, like I would not go further. I'll just leave it and move on. Okay. All right. So let's have you guys try a student practice of one of those. Go ahead. Try that. Wrong.
No,
Oh.
you just have to multiply it by 2.
Oops.
Yeah,
Um,
oh my God.
Good. I did that on purpose. Stop. Don't hurt my feelings. By the way, there is a shortcut. Like, instead of multiplying each one by 2, if they're all being multiplied by the same thing, what you could do is you could just add all those up and then double the final answer. That works too. That would work because like it's like distribution, right? This means the same thing. So you could do that. Now something that I haven't been talking about too much, but you really do need to pay attention to, because every problem I've given you, we always use the entire table, right? But you really got to pay attention to these things because this is what we really care about. Technically, I could have changed this question and I could have said, I could say 0 to 3 or something, right? And then you would only look at that much of your table. So technically, just be aware, you should be looking at this mainly before you start hitting up your table. That question kind of occurred to me yesterday while I was working. Like, what if we had something like that? All right, so now we're going to talk about trapezoid sums, okay?
Okay.
First of all, I want to review some basic geometry with you guys. We don't usually spend a lot of time finding the heights, or I'm sorry, the areas of trapezoids. So first of all, what I want you guys to understand is that the side that makes a 90-degree angle with the parallel sides is called the height. Okay? The parallel sides are what we call the bases. So I'll call that base 1, and this one down here we'll call base 2. The other side doesn't get a name, as far as I know. But here's the funny thing. We're used to height going up and down, right? But the way we're going to be looking at on the graph, where's the height at?
Side.
Yeah, so we're going to call, unfortunately, we're going to call this the height, okay? And these guys are the bases, just so you know. Now, how do you find the area of a trapezoid? The area of a trapezoid is height over 2 times the sum of the bases. And you'll have to memorize that. They won't give you that formula on the test. So height divided by 2 times the sum of the bases. So that's it. Now the cool thing is, you know how we've always been kind of struggling with how to draw the pictures for these things? I think trapezoids, in my opinion, is the easiest one. It's the easiest one to draw. So let's go ahead and start there and actually do a drawing problem. So, ready? So with trapezoids, what's different is the tops are not horizontal, right? The tops skew. The tops go from one point to another with a straight line. So you're just going to connect all your dots with straight lines. So boom, 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 boom. Just like that. Just connect all your dots with straight lines. And then what we're going to do is we're going to break up the picture into trapezoids now by just going straight to the x-axis like we always have. Now, this is kind of unfortunate, but I included this problem on purpose because you'll run into this. There's one trapezoid, right? That looks like a trapezoid, doesn't it? How about this guy? That looks like a trapezoid. This does not look like a trapezoid. So we're actually going to do the area of a triangle for that one, just so you know. Sorry, it happens that way. That's tough. Compliments of Tavia. There's another one. That one's also a triangle. All right, but the last one over there, we're back to trapezoids again. So hopefully you guys are seeing that now. So it's easy to draw. Like I think it's just really simple to draw these trapezoids. You just basically connect all the dots with straight lines and then straight down and up to the x-axis. But if you ever go from top to bottom, like above the x-axis to below, you're going to lose a trapezoid and it's going to become triangles instead, just so you know. Okay? All right, so let's go ahead and do this. We need to find the area of each one. So it's half the height times the sum of the bases. So for my green trapezoid here, the height is the distance from here to here. So what's the height? 2. Now, what are my bases? The bases are these ones. What are those bases? 3 and 1. There you go. Well, this is just 1, so we don't really care about that in this case. 3 plus 1 is 4, so we're good. There's the area of the green trapezoid. Okay, let's do the pink one. What's the base? 2. Let's fix that. And what are the bases? 1 and 4. So what's the answer? 5. Okay, now for the triangle. I actually tried to draw this a little more carefully, so let me back up a little bit. And if you guys want to as well, you can. I actually intended, and I've always made it work out this way, so that when you draw this, it should cross right at a nice number. I meant to have it cross there at 2, just so you know, because if it doesn't cross at a nice number, you got a problem. So if you didn't get it to hit 2, make a little adjustment. I meant to do that and I forgot about it. Because if it doesn't cross at 2, then you're going to have a really hard time figuring out what your base is and stuff. There's a way to do it, but it's a nightmare. And I don't think that they're ever going to torment you with stuff like that. So check this out. We have the base of this triangle is what? 1. You guys know how to find the area of a triangle, I hope?
Height times base over 2.
Yeah, so it's base times height over 2, right? Same thing. It's the same thing as a trapezoid. There's just one base, right? That's it. Instead of B1 plus B2, it's just B. So we have, what's my height? What is my height of this triangle? You could say either one, honestly, it doesn't matter. We'll just be consistent. We'll say, okay, this is my height's 1, okay? And then what's my base? The base we're going to say is that number there, right, which is 4. And so that's 2. Now let's do the other triangle. What's the base of that triangle? 1. And what's the height of that triangle? 4. Now, we have to do this on our own. You have to remember that it's negative, right? Because it's under the line. You guys good? All right, last trapezoid. Ready? Here we go. Base is 2. I'm sorry, height is 2. Bases are 4 and 1 for an area of 5. Add everything up, and you're going to get 14 as your final answer. Oh, the 5 is negative. You're right. My bad. So you end up with just 4. Sorry. So it is 4, right? We're good? Because these cancel, right? These cancel, and all you're left with is 4. What's wrong? Oh, thank you. You're right. So that should be a 1, right? Or 4 plus 1? Getting ahead of myself. Sorry. 4 plus 1. Those are the bases. So like, here's your 4. Here's your 1. It is. So I just do it mentally. Like, I think of this as just geometry over here, but when I come over here, I just mentally convert it to negative if it's underneath. But what you're suggesting is fine. You could call this a -4 because it's down 4, right? And you can call both of these negatives, and you'll still get the right answer. So you could do it that way if you prefer. Any other questions? All right. Now, I want to show you guys something that's a little bit weird. And it's so funny because it didn't make sense to me before, but now it does. But watch this. Instead of treating these as 2 triangles, watch what I do here. From here to here, the 2 triangles, what's the base? Or sorry, the height? 2. What are the bases? 4 and -4, right? That's what the 2 triangles add up to anyway. So you can actually still treat it like a trapezoid even though it's not. Kind of weird. But there you go. So there's your thing. So let's see how you guys do with this one. We'll kind of group practice this one. So let's do it. I'm gonna have Orion. Could you come up here and do my first step to draw my trapezoids for me? You know, I'm going to make it work out a little bit better for us. I'm going to actually have us use a line thing so it comes out straight.
So I just kind of like.
Oh, it needs to be black. Sorry. Try it again. Good. 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 And good. See, by using that line drawing. Okay, he's going to keep going. By using that line drawing thing, I got it to cross at a good point this time. Because if your lines aren't straight, it won't cross at a good point. Thank you, sir. Yeah. All right, so I'm gonna go ahead and color in all of our things here. But you guys are welcome to start finding your. Go ahead and start finding your areas of each one of these pieces and see if you can get the final answer. Triangle there. Okay. Okay, so there's our answer. Now, before I move into the table problems, let's look at our bases here, right? My bases are from how far apart each x value is. Oh, you're right. You're right. So my height is how far apart each of the x's are, right?
Yeah.
So we're looking at that. I'm going to leave the triangles off for now on purpose. We'll get to that in a second. But what y values do we use for the bases? Use both of them, right? So you're going to, when you're doing a trapezoid sum, so remember we did left-hand sum, we left off the right one. When we did right-hand sum, we left off the left one. When we do midpoint sum, we leave off both of them, we pick the one in the middle. But with trapezoid sum, you use every y value because they both make up your bases. And in fact, that some of the y values get used twice, like this one, right here in the middle. It gets used as a base for this blue trapezoid, and it also gets used as a base for the pink trapezoid. Okay, so the only ones that won't get used twice are the ones on the end. Now let's talk about the triangles on the end. When you're looking at a table, you're not going to see that as triangles, obviously, right? But the good news is it doesn't matter. It still works. Let's just say we're going about this blindly. How far apart are my two x values? They're still 2. That would be my height. And what would my bases be? They would be the two y values. What's the y value for the first one? And what's the y value for the other one? And that's 0. And that's 1, so the answer is 0. The triangles just cancel each other out anyway, right? Now, I picked the triangles so they always end up being exactly the same. They don't have to be the same, but the point, it still works. You could still do the trapezoid formula for two triangles. It just works. The reason why, I just realized that works, I was sitting there doing all kinds of complex algebra to figure out why that works, and I just realized why it works now. Because if you just distribute in your thing, you just get two triangles being added together.
Oh, pretty cool.
No? I was working on this for like 30 minutes, and I just realized it. It's just like, you guys got to be excited here a little bit.
Yeah. No. Earth
Day. All right. So let's do an example of tables without looking at graphs now. Because like I said, it's pretty rare they're going to give you an actual graph. Some of your integral review for this week has those on there. But they are graphs, but still. Usually on the AP test, there's tables. So here we go. Use a trapezoid sum to estimate the definite integral below using the table. So we're going from 0 to 8, right? That's the whole table. Remember, you're not always going to use the whole table. It depends on what they ask for. I just kind of always do that. All right. So what do these represent here? Kind of. Those are my heights. Because remember, on a trapezoid, the horizontal ones are actually the heights. So we're going to call those the heights. I know. Now, these are my heights. And we use the bases. And we're going to use all of them. So, for my first trapezoid that I'm going to work with here, I'm going to color code. For my first trapezoid, from the first x value to the second x value, what is the height of that trapezoid? The height is 1, right? What are the bases of that trapezoid? It's the y values. Does that make sense?
Okay.
All right, let's do the next one. My next trapezoid is going to be from 1 to 2. What is the height of that trapezoid? 1. And what are the bases of that trapezoid? It's the y values. I didn't hear you, sorry. All right, next one. My next trapezoid is going to go from 2 to 6. What is the height from 2 to 6? What are the bases of that trapezoid? Matthew said, I don't know. Are you guys getting this? You just ignore me. I don't know what's happening right now.
I got it.
Okay, I just want to make sure you guys are getting it. You guys are being quiet. All right, what's the base of my, or height of my last trapezoid? 2, good. It's the same person, though.
No, I didn't answer the other ones.
Oh, was that you? I thought it was Matthew making a different voice, messing with me. Okay, good job, Ryan. Thank you.
Yeah, I just sound
You sound like a what?
female. I have a very high pitched voice.
What you saying? You sound like a female? What?
I know, but like that's why he made a voice. What did you do? I know you
That's funny on a lot of levels. Okay, here we go. What's that? What?
16.
16 over 2, right?
Yeah, 8.
Next one.
17 over 2.
Last one. Ooh.
15 times 2. 30.
I like to leave it. I'm going to leave it over 2 for now. Just bear with me.
Fine.
15 times 4 is 60, right? Now, let me tell you why I'm doing this. Ready?
So you can easily add them all.
Yeah, because you got to add these all together. So if you just leave them all over 2, it just kind of makes it so you already have common denominators. But however you want to do it's fine. Just make sure you do it. So that's the final answer? So we have 16 and 17 is 33, plus 60 is 93, 113 and 117. So we have 117 over 2. And I'm just going to leave it like that. Or if you want to make it 58.5, you can. Or you could just do this, honestly, unless it's a multiple choice test. Just put a plus in between all of them.
Mr. Bailey.
Hi. I can.
Sorry. Wouldn't the last one be like just 7 plus 5 is 2 over 2?
Yeah, so you can, so I didn't want to simplify them. I just wanted to do like, what I did was I just did this times the top number and wrote it like that. The reason I did that is because now they all have the same denominator and it's easier for me to add them together that way. But if you want to simplify them as you go, and let's say you get lucky and they all turn out to be even numbers that can be divided by 2, okay, that works too. All right. It's just that a lot of times I find they end up being odd, and then you got to go back and put them all over 2 again to get your answer. So, all right. So last one, we made our mark. This is where we're going to stop for the day. So go ahead and show me what you got here, and
Oh, so really, do you know?
What was the name of that movie when it was like understood for time was like deciding the whole